Hello everyone, Namaskar. Welcome to Maths Guidance and welcome to the new chapter of this series, that is chapter number 8, quadrilaterals. So we are going to study about quadrilaterals, and the main focus will be on parallelogram. It's a special kind of quadrilateral that is called parallelogram. So yes, there are lots more things to study in this chapter. So let's start the chapter and let's see how it comes out. Today will be the first lecture. Okay, so let's start. So guys, let's start the chapter quadrilaterals and let's start with the introduction. So all of you know that when you join 3 points or 3 non-collinear points, then you get a triangle. Okay, introduction, let's write introduction. So basically when you join 3 points, these are collinear points. If you join these collinear points, you will get a line segment. All right, but if you join 3 non-collinear points like this, you will get a triangle. Okay, all of you know and you have studied in chapter number 7, that is triangles. Now what happens when you join 4 points? So first case is when you join 4 non-collinear points, you will get like this, again a line segment. If the points are like this, 1 2 3 and 4th is in this line, then also you will get a triangle, because here all 3 are collinear, so you will get a triangle. Now the third case is when you join these points. There are 4 points set in an order, so you will get a closed figure, and this is what we call quadrilateral. All right, and one more type of quadrilateral is this one, 1 2 3, and let's see, one is here. You join like this, 1 2 3 4. This is also one type of quadrilateral, but our focus in this chapter will be on this one, quadrilateral. All right, this is called kite. We will study something about this, but the focus will be on this quadrilateral. All right, and different types of quadrilaterals obviously we will study. So what is a quadrilateral? First of all, quadrilateral, it's a closed figure. Quadrilateral, it is a closed figure, formed by 4 points set in an order. Okay, and a quadrilateral has 4 sides, 4 vertices and 4 angles. Let us suppose this is A, this is B, this is C, this is D. So a quadrilateral has 4 sides. Obviously you can see AB, BC, CD and DA. AB, BC, CD and DA. Okay, it has 4 angles. What are the angles? Angle A, angle B, angle C and angle D. And it has 4 vertices also. 4 vertices. Vertex A, vertex B, vertex C and vertex D. Alright. So a quadrilateral has 4 sides, a quadrilateral has 4 angles and a quadrilateral has 4 vertices. Okay. And when you join this, if you join this, let us say this is a quadrilateral A, B, C, D. When you join the opposite vertices, then you get the diagonals. So AC and BD are 2 diagonals. Of quadrilateral. You can also write quadrilateral like this, A, B, C, D, or you can write quadrilateral A, B, C, D. These are the symbols. So you can write like this or like this. So AC and BD are 2 diagonals of a quadrilateral. Now the point is, why are we going to study quadrilateral? If you see on your daily life, you will look at so many things. Suppose your TV, its shape is of the quadrilateral. Your table, whether it's your study table, your dining table, it's quadrilateral shape. Duster, Duster is also quadrilateral shape. Your books, notebooks, whatever, notebooks, even your mobile phone, all are of quadrilateral shape. Are of quadrilateral shape. Quadrilateral shape. So that is why we need to study quadrilateral, and we will study. All right. Now let's move on. Let's start with one simple property of quadrilateral. Just as in a triangle, it was the angle sum property. Angle sum property of a triangle. Angle sum property we had studied of a triangle, that all the angles make 180 degree. So similarly, we will study angle sum property of a quadrilateral. Angle sum property of a quadrilateral. Okay. So let's move on to this topic. Okay, now let's start angle sum property of a quadrilateral. So what is angle sum property? That the sum of all the angles of a quadrilateral is 360 degree. The sum of angles of a quadrilateral is 360 degree. All right. Like in triangle it was 180 degree, here it is 360 degree. So we see how we get this one. We will prove this theorem. Okay. So let us see. If this is a triangle, quadrilateral A, B, C and D. Okay. We are going to prove this one. The sum of the angles of a quadrilateral is 360 degree. So let ABCD is a quadrilateral. And we will draw a diagonal like this. And BD is a diagonal. Now we know that the sum of the angles of a triangle is 180 degree. So triangle A, here there are two triangles ABD and BCD. So in triangle, let's see this one ABD. In triangle ABD, this angle A plus this angle ABD, all right, and plus this angle ADB, that is equal to 180 degree. Let us suppose this one first equation. Now in triangle BDC, what we have? Angle C plus angle CBD plus angle BDC, that is equal to 180 degree. We know these two from angle sum property of a triangle. Angle sum property of a triangle. Now when we join these two equations on adding equations 1 and 2, what we get? We get left hand side angle A plus angle ABD plus angle ADB plus this one angle C plus angle CBD plus angle BDC, that will be equal to 180 plus 180, that is equal to 360 degree. Now we see what is on the left hand side. Angle A plus angle C we can write. Now we will take angle ABD and angle CBD. Okay, this one and this one we club together, plus angle ABD plus angle CBD. We can do like this, plus this and this, angle ADB plus angle BDC, that will be equal to 360 degree. We can write like this. This implies angle A plus angle C plus angle ABD plus CBD. So ABD plus CBD, that means angle B. You can write angle B. Here ADB plus BDC. So ADB plus BDC, that means angle D. plus angle D, that is equal to 360 degree. That means angle A plus angle B plus angle C plus angle D, that is equal to 360 degree. So we can say that sum of the angles of a quadrilateral is 360 degree. That is sum of the angles of a quadrilateral is 360 degree, proved. So it was a simple proof. Just we drew one diagonal and then two triangles are there. So we proceed and we get this property, this theorem. All right. Now let's move on and let's see what are the types of quadrilaterals. Now let's study the types of quadrilaterals. All right. So I am going to draw some figures. Let's see this one. This is one of the figures. All right. Let us suppose this is A, B, C, and D. This is figure number 1. Okay. Now second one is like this. Let us suppose this is P, Q, R, S. This is figure number 2. Third one is like this. This is figure number 3. Okay. Now the fourth one is like this, figure number 4. Now the fifth one is like this, fifth one, and the sixth one is like this. Sixth one. Let us name it A, B, C, D, P, Q, R, S, M, N, R, P, D, E, F, G, A, B, C, D, A, B, C, D. So we have drawn 6 figures. Now let us discuss one by one. Let us discuss first one. First one is, you can see that this side and this side are parallel, means AB parallel to CD. All right, and this is not parallel. AD and BC are not parallel. So mainly one pair of opposite sides are parallel. All right, one pair of opposite sides are parallel. One pair of opposite sides are parallel. Namely, here it is AB parallel to CD. All right, AB parallel to CD. Now this will be called a trapezium. Okay. If one pair of opposite sides are parallel, then it is a trapezium. So the figure of trapezium is like this: parallel sides, non-parallel sides. Okay. This is first one is trapezium. Now the second one, this one is, I hope all of you know, this is a parallelograms. Here both pairs of opposite sides are parallel. This one is parallel, this one are parallel also. Okay. So both pairs of opposite sides are parallel, then it is called a parallelogram. Both pairs of opposite sides are parallel, means PQ parallel to RS, and PS parallel to QR, Now this is called a parallelogram. Parallelogram. All right. So this is a parallelogram. Now if you look at this figure, this one and this one, all these are parallelograms. 2, 3, 4 and 5, all of these are parallelograms because opposite sides are parallel. But there are some other names also for these quadrilaterals. We will discuss. Let us suppose third one. When you see opposite sides are parallel, no doubt you can see opposite sides are parallel, but one of the angles is right angle. Angle M is a right angle. Okay, so this is called a special type of parallelogram called rectangle. All of you know, one angle is right angle, one angle is a right angle, and opposite sides are parallel, of course. Opposite sides are parallel. So it is a rectangle. Now come to the fourth one. Here you can see that all the sides are, this is called a rhombus. Okay, here all the sides are equal. All right, so all the sides are equal, then it is a rhombus. All the sides are equal, then it is a rhombus. But here it is not 90 degree. All right, so all the sides are equal, it is a rhombus. Now the fifth one, this is a square. All right, here all sides are equal, but the angle is also 90 degree, right angle. All the sides are equal, and one angle is 90 degree. So this is a square. Later we will study more about this, that basically all these four angles are 90 degree. We will study later on, but the criteria is this: if all the sides are equal, then it is a rhombus. All the sides are equal and one angle is 90 degree, then it is a square. Now the sixth one, here these two sides are equal and these two sides are also equal. So basically it is called a kite. So in a quadrilateral ABCD, if AD equal to CD and AB equal to BC, that is two pairs of adjacent sides. These are called adjacent sides. All right, two pairs of adjacent sides are equal, then it is called a kite. It is not a parallelogram. Okay, so two pairs of adjacent sides, sides are equal, then it is called a kite. It is not a parallelogram. We write like this, parallelogram. Okay, so basically 2, 3, 4 and 5 all are parallelograms. This one is trapezium, this one is parallelogram, this one is rectangle, rhombus, square, and this one is kite. This is not a parallelogram. All right, so when one pair of opposite sides are parallel, then it is called a trapezium. When both pairs of opposite sides are parallel, it is called a parallelogram. And when one angle is 90 degree, it is called a rectangle. When all sides are equal but not 90 degree, so it is a rhombus. And when all sides are equal and one angle is 90 degree, it is called a square. So I hope all the types are clear now. Let's move on. Let's study something else, more about quadrilaterals. Now let's discuss some important points to remember. So the first point is a square is a rectangle and also a rhombus. First one is a square is a rectangle and also a rhombus. But how? The rectangle is like this. The rectangle is like this. The rhombus is like this, and a square is like this. So a square is having all the sides equal, all right. Rhombus having all sides equal, but the square is having one different thing, that angles are 90 degree. Rectangle here also 1 degree 90 degree, but all sides not equal. Rectangle having opposite sides parallel only, okay, and opposite sides equal, but not all sides are equal. So we are writing that a square is a rectangle. A square is a rectangle. We can write, because the minimum criteria of being a rectangle is 1 degree 90, one angle 90 degree, and the opposite sides are equal and parallel. So here we have, so a square is a rectangle, and also a rhombus. Rhombus, all sides are equal. Here we have all sides equal. So a square can be a rectangle and a rhombus. So we have to remember this, all right. Now the second one. Second one, it's opposite, that a rectangle or a rhombus is not a square. A rectangle or a rhombus is not a square. Is not a square. You can know from this thing. Rectangle, a rectangle has not all the sides equal, so it cannot be a square. A rhombus has all the sides equal, but the angle is not 90 degrees, so it cannot be a square. All right. So a square can be a rectangle and rhombus, but rectangle and rhombus cannot be a square. These are the two important points. Now the third one is a parallelogram. A parallelogram is a trapezium. Is a trapezium. A parallelogram is like this, that both pairs of opposite sides are parallel. Trapezium is like this, only one pair is parallel. So this is a parallelogram. A parallelogram is a trapezium. So parallelogram is fulfilling the minimum criteria. One pair of opposite sides are parallel. Here both pairs are parallel, but one pair is at least parallel, so it can be a trapezium. So a parallelogram is a trapezium. But if you see the opposite of this, a trapezium cannot be a parallelogram. So a trapezium is not a parallelogram. The fourth important point is a trapezium is not a parallelogram. Is not a parallelogram, because in a trapezium only one sides are parallel. Because for parallelogram we need both sides, both pairs of opposite sides parallel, but here it is not. So a trapezium cannot be a parallelogram. Parallelogram can be a trapezium, but trapezium cannot be a parallelogram. This is the difference. Fifth one is a kite is not a parallelogram. A kite is not a parallelogram. As I have discussed, the kite was like this. Here only these sides are equal, all right. So it is not a parallelogram. So these are the points, 5 points which you need to remember. Now let's see one more thing, the relation between rectangle and parallelogram, all right. This is one rectangle. This is one rectangle and this is parallelogram. Let us suppose this is A, B, C, D. Here it is A, B, C and D. And the sides are 4 centimeter, 3 centimeter. Here also 4 centimeter and 3 centimeter. Okay. So the if you see the area of a rectangle, here it comes out 12 centimeter square. 12 centimeter square rectangle. And what is the area of a parallelogram? Area of a parallelogram is, it is the perpendicular from here, and when you multiply this one side AB, and let us suppose this is DP. So AB into DP. For parallelogram, the area is parallelogram. The area is AB into DP. Now, if you see, this AB is same 3, but this DP is going to be less than this DA or AD. That is why the area of a parallelogram is less than the area of a rectangle. So, area of parallelogram is less than of rectangle. All right. Area of parallelogram is DP multiplied by AB, DP multiplied by AB, and which is always less than the area of the rectangle, that is AB multiplied by AD or AB multiplied by BC, whatever you can say. So the main point here is, if you see in a sweet shop, the burfis are always of this shape, parallelogram shape. Okay, basically it remains of this shape, but these are in the shape of parallelogram. Why? Because they cover less areas. Okay, so shopkeepers prefer to cut the pieces of burfis in parallelogram shape. Shopkeepers prefer parallelogram shape burfis or kaju katli, whatever you say, burfis. Okay, because parallelogram covers less area. Parallelogram covers less area than a rectangle. So he is in gain always. He will make more profit. So the shopkeeper prefers burfis of parallelogram shapes. All right. He can accommodate more pieces. That is why. Okay, so these are the important points. Now let's move on. We will see some other things. So friends, we have seen the definition of quadrilateral, and we have also got to know the types of quadrilaterals, the angle sum property of a quadrilateral, and also in the last part of this lecture 1 we have discussed some important points to remember, always to remember, that what is basically the difference between rectangle, square, parallelogram, trapezium, and kite also. All right. So our main focus will be on parallelogram. Later on we will study. Let us conclude this lecture 1 here only, and in lecture 2 we will discuss some problems based on whatever we have studied. Then on lecture 3 we will move on to the properties of a parallelogram. All right. So let's study slowly so that we can understand all these things, and please be connected with my channel. Thank you so much for watching my videos.